I left you and our ferrocene was up here, and now it's down here, and we have a slow drip, much too slow for our liking. So I want to remind you what this purification technique is called. It's called column chromatography. If you want to speed it up using pressurized air, its name changes to flash column chromatography. So if you're asked about flash column chromatography on the final, you'll know that this is the setup, and you need some source of pressurized air. Cross your fingers, it's our first time using this source of air in this experiment. And I want to try to speed up that flow down there. Oh, mission accomplished, I like that. I don't want a stream down there. Drops are cool. Stream is too fast. And we see the ferrocene is now going into this flask. It's yellow. If you take a look there, there's yellow liquid in there. I want to keep collecting until I'm 100% sure the ferrocene is finished. Ferrocene's still down here. And I can go a little extra just to be extra safe. Do not ever let the liquid go below the sand surface. That is to say, you need to keep adding liquid. I'll be doing that after I'm finished with my ferrocene. We're pretty close. There you go. I'm pretty sure the ferrocene is gone. So I'm going to do a few things. I'm going to top up my solvent. Not too high because I don't want it splashing when I put the air on next time. And I'm going to switch to flask 2. And at this time, your lab partner would take flask 1 into a fume hood, put it in warm sand, and blow air on it until all the solvent was gone, leaving you with yellow crystals called ferrocene. And that's recovered reactant, right? It's not the product, it's the reactant. And you would calculate what percent ferrocene didn't react. We don't need to do that, but that's what normally happens. Flask 1 is done. Flask 2, I'll get it started and then we'll do a video break. I want to get it to where I have just less than a stream. Fast drops. That's pretty good. And there's no product in there yet. We chose a reaction that has colored products. That's nice. Before we conclude this segment, I'll tell you what you have to do for most chromatography experiments like this. How am I going to decide which flask to use when the products are invisible? Very good question. So we'll come back to this later. I will just verbally describe how I did every column I did in graduate school. You get a rack of test tubes, more than 100. They're good sized test tubes. They hold about 40 milliliters each. Okay? And you just fill a test tube, switch to the next test tube. Fill a test tube, switch to the next test tube. Keep doing that until all 100 of your test tubes are full. It's not fun work, you can tell. Okay? But it's worth it. And then how do you figure out what's in each test tube? You get a TLC plate like the one before I cut to a smaller size. And you put 100 marks across the bottom. You do spots on each lane representing test tubes 1 through 100. Then you put it in a big old chamber for TLC and then you take it under a UV light where your spots are visible, and you start shading things, and you'll see test tubes like 20 through 35 had the one product, and maybe test tubes 50 through 75 had another product, but then test tube 76 through 79 had two products. They were a mixture. I'd throw those test tubes out. The contents are of no use to me. But maybe test tubes 90 through 100 had the third product in them by itself, and I would pour all of those into a flask and evaporate the solvent, and there you have your product. Got it? So I think that's a good segment for video, and we'll stop.